Hi guys, I am Kunchanapalli Manohar from Bennett University, a BTech second year CSC student. So now I'm going to talk about multi-threading, which happens to be one of the most famous topic in OS, and also happens to be one of the most famous topics for interviewers. Right. So what exactly is multi-threading? So when I first started to explore about multi-threading, this was the first definition I actually came through. In computer architecture, multithreading is an ability of a CPU to provide multiple threads of execution concurrently, supported by the operating system. This approach differs from multiprocessing. Pretty heavy and weird definition, right? So in this video, I'll try to explain you this particular definition, break it into different parts, and try to explain you what exactly the multi-threading is. So in this video, we'll talk about what exactly a thread is, what is what is multi-threading, what are the real life implementations of multi-threading, how multi-processing and multi-threading differ from each other, and as everything in this world has some kind of drawbacks, what are the drawbacks of multi-threading? So, so moving on to what exactly is multi-threading. So, if you go by the definition of a thread is a single sequential flow of control within a program. So, as programmers, all of you are familiar with sequential programs, right? You've probably written a program that displays, say, for example, in Hello World, or sorts a list, or say prints a list of prime numbers. These all are sequential programs. That is, each of it has a beginning, has an execution sequence, and an end. Another interesting thing about thread is it cannot run on its own. A thread takes advantages of the resources allocated for that program and the program's environment. And since it carves out the resources from the running program, it is very light. For example, if we see this particular diagram here, so you can see this is a particular program and this is a particular thread. So for example, say if you're writing a hello world thing, so this thing might be the start. Here you are printing it, and this might be the end of that thread. Okay. So another okay, so moving on, what exactly is multi-threading, right? So the turns out to be the real fuss around thread is not about its sequential running. It turns out that the fuss around it is involves in actually the multi-threading ability of it. So like for example, say I'll explain it to you using a video. So for example, say we've all done searches on Amazon, right? For example, if we go to this amazon.in, right, if we go to the site called amazon.in and search for something, say shoes for men. So here, when you actually search for shoes for men, the screen does not actually get freeze. What it exactly does is creates another thread. It sends the request to the server, and once the results come, it actually gives you back the results, right? So, for example, like here you searched for shoes, so it creates a thread for requesting, and after that, it once the results have loaded, it shows you those results. Okay, so I'll tell you more about more such examples. So these days we all have we have PCs and laptops which have multiple core CPUs, right? We have quad cores, octa cores, etc., etc. Right. So so, for example, say you write a program, you have an array, and you write a program for multiplying a list of numbers, a list from 1 to 100 by 2. So, if you simply write a program, so multiplying it, and you simply just write a single command, it will use only one particular thread of or one particular processor of your CPU. But whereas if you actually use multi-threading and create four different threads, for example, say you have quad-core CPU and you create four different threads. So rather than taking, for those say 8 seconds for the multiplication of a list, it will take you 2 seconds. And and it is actually very realistic in, for example, say musical apps. So for example, you are listening to a music, right? So parallelly what you can do is you can search for another song, whereas search for a song, and meanwhile where it actually gives you back the result, the music which is actually playing keeps on playing, it does not actually stop. So that is what you can exactly see the multiple threading taking place. So we have one thread which actually plays the music, and you have another thread which actually gives you the results for it. Okay, so we've talked about multiple threading, right? So, and I told you that this thing is actually harnessing the multitasking ability of your CPU. So, what is actually multiprocessing? Turns out to be that the central idea of both the things are the ability to harness the multitasking ability of your processor. So, if you to the closely look at the diagram at your right, you have say three processes there in a single OS, and each of the processes has different threads on it. I mean, you have three threads in one, two threads in another, and one thread in the last one, right? Right. So this is exactly what, if I have to explain it in a diagrammatical way, this is what is the difference between multi-process and multiple threads. Multiple thread happens in a process, and multi-processing happens in your OS. So multi-processing is like you're running two different apps, and multi-threading is actually you're running different things in a particular app. If I have to talk the technical aspects of it, right? So, for example, in multiprocessing, each process allocates a separate memory area, whereas in multi-threading, threads share the same address space. Okay, and as I said earlier, since a thread harnesses the capabilities of a process, it is much more lighter than a process. And since through two threads share the same address space, the cost of actually exchanging some information between two threads is way less than the cost involved in sharing information between two different processes. So I guess by now you have a decent enough idea about what exactly multi-threading is and what are the differences between multiprocessing and multi-threading. Coming to the last topic of my presentation, I'll talk about the different issues in multi-threading. Number one, concurrency. It is difficult to handle concurrency in multi-threaded processes. This may lead to complications and future problems. Number two, deadlocks. One of the most terrifying things in the world of OS is deadlocks. Though we have a lot of solutions around deadlocks, still preventing a deadlock amongst two threads can be a very complex task. If it happens that you face a deadlock between two threads, it can actually tend to force shut down your process or app. Number three, identifying the errors. Since implementing multi-threading is a very complex task, identifying an error in that thing is also not an easy job. It requires a lot of skills and has a lot of complexity in it. Coming to my last point, by now you must have realized that multi-threading is not an easy thing to implement. So in the same lines, when you're actually doing exceptional handling for multi-threading, you have to take in a lot of considerations into mind and program it very carefully. All these points go to show that a multi-threaded programming a multi thread programming multi-threading is a very complex affair and can be done by expert programmers only. So these were a few things that I wanted to talk about. I hope you guys got a decent idea about what a thread is, what is multi-threading, how it harnesses the multitasking abilities of the processor, and what are the different challenges faced while implementing, or what are the different challenges around multi-threading. I hope it helped you to gain an idea about this topic. Thank you.